Yo, what's up, geometry students? Let's get ready for a big quiz on a bunch of stuff. Lengths with numbers, Pythagorean theorem, circles. We got to be ready for square roots. Square roots, it's important to understand what the biggest square root that can be kind of like pulled out of each number. What I like to tell my students is you need to try to divide all of these perfect squares into our number. You got to try to pick your biggest one. Because sometimes if you pick something that's not the biggest one, like 4, you think that things are simplified when in reality, there's not. And you could end up in a situation where you don't get the most simplified when you do need that, not that. So, this is the long way. Let me show you the short way. You would have figured out that 16 goes into 48 3 times. Root 48 is root 16 root 3, so you got 4 root 3 right there. Ooh. 117. And try 49. This is one if you have a calculator, it's going to be really helpful. 49 times 3, 7. 12. No, that's obviously not right. 9. Just showing you how if you don't have a calculator, you can still do it. Cool. 9 times 3. 9 times 13. 9 times 13 is 117. Root 9 times root 13 is root 117, 3 root 13. This is a good example because it shows you like what might happen if you go the long way. 9 goes into 18 twice. So I have this 3, leave the 3. But then I have a root 9 root 2. 9 times 2 is 18. Root 9 times root 2 is root 18. This becomes 3 times 3 times root 2. This becomes 3 times 3, which is 9 times root 2. Cool. Now, what if I have 5 root 2 and I want to square it? This is not really simplifying the other ways. This is like multiply. And it's very interesting. I don't think we've done this much in class, but like, what if you take 5 root 2 and multiply by 5 root 2? Like, that's what squaring is just taking something and multiplying it by itself. Well, like, what if it was like 5x and I was squaring it and you had 5x times 5x? Since it's multiplication, you know we can multiply things in any order. Like I can decide to multiply the 5 and the 5 together and the x together. So I realized that I can multiply the 5 and the 5 and the root 2 and the root 2. You can do multiplication in any order. There's no distribution. There's no addition or anything. So I get 25 times root 2 times root 2. Well, just kind of going backwards, you can multiply the roots and you get root 4. Oh, isn't root 4 just 2? Don't you get the answer 50? What you'll notice is that square roots undo squares. You know, like 4 squared is 16. The square root of 16 is 4. It's kind of like you will undo what's being done with square rooting and square. So like if you think about root 2 squared, it's 2. So root 2 times root 2 is root 4, which is 2. So boom. All right, so that's good review. Not review, but that's good. Just like preparation for simplifying square roots. Now let's get to the heart of the matter, which is like line segments in a coordinate plane, understanding in coordinate planes, vertical lengths, horizontal lengths, easy to find. Diagonal lengths, there then can be found, and then a bunch of stuff can be done. So here's what I tell my students. once we have a line segment down, is to use your friend the like the T-chart, because the T-chart really has everything you need. But like, be careful. Don't abuse it. Sometimes you have to really pay attention to what the question's asking and what T-chart you need to be looking at. I have X's and Y's. I have -3, 4, and then I have 3, -4. Well, I can see from -3 to 3, I can subtract the 2 to find the length in between the two. So 3 minus -3, we subtract to find lengths. This is like x2 minus x1. This is 6. 4 to -4. Well, y2 minus y1 is, sorry, y2 minus y1 will give you the y distance, or you could figure out, oh, I added 6 here, I subtracted 8 here, and this is how you find it, by subtracting the numbers. What does that mean? Well, that means like here, this length here is 8. Maybe you could say you went down 8, or you went a y distance of -8. This length here is 6. Cool. You have a slope right there. Rise over run. Cool. You have the legs of a right triangle, and you have an a squared plus a b squared, which equals a c squared, which is a very, very important, almost one of the most important formulas in mathematics, where you could say, okay, a squared plus b, let's say you say the b is -8. Let's say you said the a was -8. That's fine. If you're going to use a calculator, make sure you put in parentheses equals c squared. I get 36 plus 64 equals c squared. I get 100 equals c squared. C equals 10. Well, you could say it's plus or minus 10, but we're just going to talk about positive lengths of segments. So that's the length of segment PQ. Cool. What else can you do? It's like, I'm going to just start over because you're asked to find the midpoint. Well, what's the midpoint? The midpoint's the middle number of these 2 points. If you've already done your work of figuring out this length and this length, you could just go halfway for both situations. Like -3 plus 3 is 0. 0 plus 3 is 3. Oh, plus 6 gets you all the way. 4 minus 2. 4 minus 4 is 0. Minus another 4 is -4. Or that's going the entire way of -8. This is one way to find the coordinates, and it's a coordinates system. So people are like worried. They write it's like X is this and Y is this, or this and this. But like, this is the point, that's the midpoint. The other way to do it, to find the middle numbers, is to find the average. And you get zeros. Okay. Now we have the idea of a circle, where we have this point M, we have this random collection of XY points that are a specific distance away. Okay? Now, what is the distance? This is actually easy to figure out, but you could do some extra work if you wanted to, if you want to check. So here is the idea of, this is the circle. Okay, there's a circle. It contains both those points. What is this radius, this length here? And we have the center, which we know is at 0, 0, that midpoint. What's that length here? Well, hopefully you're figuring out it's 5. Let's say you don't know it's 5. Well, you need to find the length from the middle to the outside in one way or another. Now, let's say you decided to use the Pythagorean theorem again and say, okay, let's just go from 0, 0 to 3, -4. And you got -3, you got +4, and you're like, okay, -3 squared plus 4 squared equals c squared. 9 plus 16 equals c squared. 25 equals c squared. C equals 5. Cool. That's a way to figure out that this length is 5. Okay, now here comes the ticket. We want some sort of expression for all possible xy's that are 5 away from 0, 0. Well, here is the connecting piece of triangles and circles. This creates a triangle. Now, like, I'm starting over again. I'm talking about 0, 0 to xy. What is the distance from 0 to x? What's the distance from 0 to y? Well, you could say it's x minus 0. You could say it's y minus 0. This length here is x minus 0. This length here is y minus 0. You could put this and this and this into the Pythagorean theorem. A squared plus b squared equals c squared. And let's see what that would look like. A squared plus b squared, and now this is the important thing that students mess up, equals c squared. C squared is 25. And this is your equation. Now, what about the equation of the line? Like, we could talk about how we could use these numbers and we could think about the fact that all of the points x, y on this line have to follow a certain ratio, but I'm not going to get into it. Instead, what I'm going to know is like the equation of point slope for a line comes from the slope formula. All we need to do, just like we do for equations of circles, is hold the x, hold the y. So don't change the y, don't change the x. But we need to find information, just like we found the information here of the 5. We need to find the slope. Well, we already found the slope earlier. Remember, the slope came from our friend Mr. T-chart. But please, please, please do rise over run. Y's over x's, because we got x's and y's in this fashion. We need y's over x's. So make sure you calculate the slope is rise over run. Okay. Take that and take either point. Let's say we use this point. I'd have y minus 4. That's my y distance between a point I know and any other y coordinate. I got -4/3, and then I have my x distance between an xy and any of the x coordinates. It's, again, just using another triangle, but I'm not going to show it. I'm not going to worry about it. Next year, we'll teach it that way. Point M is the midpoint of a segment between -2, 5 and another point. I mean, this should be easy. I wish it wasn't point M. Let's use like point M and the point -3, 4. So here's the idea. You have -2, 5 as a xy, and you know 0, 0 is the midpoint. What's the other point? Well, just think about like how you could go halfway to find the midpoint, or understanding that this distance can just kind of be doubled to get the other side of things. And I get this 2, -5. It's the easiest way to think about that. If that's the midpoint, just keep going that same amount. And now you have like this distance is 4. Okay, the middle is like +2, or it's like between -2 and 2 is 0. But let's talk about point -3, -3, 4 is the midpoint between -2, 5. So like this is not as obvious. We have -3, 4 is the midpoint between -2, 5 and another point. This is not as nice. But you'll be able to at least get you another example. -2 goes to -3, goes to -4, 5 goes to 4, goes to 3. So like this would be the other point that we are looking for if you use -2, 5 and -3, 4 was the midpoint. Cool. All right, right triangles, Pythagorean theorem. A squared plus B squared equals C squared. We kind of practice what is 2 root 3. Like, watch what you could do here. Let's make it easy on yourself. Is it 2 root 4? Is it root 4 times root 3 root 12? Watch this. 4 squared plus root 12 squared. 16 plus 12 equals C squared. 28 equals C squared. If you want to, you could have done 2 root 3 times 2 root 3, and you get 4 times 3. Because 2 times 2 is 4, and root 3 times root 3 is root 9, which is 3. Okay, we square root. C is going to be the square root of 28, which is root 4 root 7, which is 2 root 7. So this is 2 root 7. Okay, what is this? Make sure you understand what's A, what's B, what's C. C is always the hypotenuse. It's always opposite. Here, I'm given an A. I am not given a B, or vice versa. And I am given a C. So 36 plus B squared equals 144. B squared equals 36. I'm going to take away 30 and then another 6. So I got 114 minus 6 is 108. And now I'm going to square root. And I'm going to figure out what goes into 108. Something more than 9. 27? 27 does. Tough. Like 27 times 4 is 108. Look at that. Twenty-seven times 27 is not a perfect square. It's a perfect cube. 36? 36. 36 times 3? 36 times 3. Yo. Just going to show you what you should do. If you are not able to do this mentally, you should be breaking out a calculator. And in your calculator, you should be taking 108 and dividing it by perfect squares. Okay, 64 doesn't work. 49 doesn't work. 36. Boom. 36 times 3 is 108. 36 is a perfect square. The square root of 36 is 6. Done. All right. Next question you will see on your quiz. It's not a question we did yet. Probably show you a couple more before we get into it. But what's the value of x here? Well, here's the idea of, let me give some space here. A squared plus B squared equals C squared. Wait, gotta use parentheses. Why? Because watch what happens. What's 2x times 2x? It's 2 times 2 and x times x. It's 4x squared. Now, how do you solve this? We can subtract an x squared, and I get 81 equals 3x squared. I divide by 3. Gotta break out my calculator. 81 divided by 3 is 27. I divided by 3 both sides. And now I can square root. And I got x equals the square root of 27, which is root 9 root 3, which is 3 root 3. That's your answer for x. You will need to do this for your quiz. Try another one. Try this one if you didn't try the previous one. This is the hypotenuse, so a squared plus b squared equals c squared. 2x times 2x is 4x squared. X squared plus 4x squared is 5x squared. If you didn't understand it, do it again. Yep. All right, what do we got here? Find 2 points, 2 easy points. Write them down. I got the point 0, 2, and I got the point 2, negative 1. What's the slope? Rise over run? Well, like y's over x's. The slope is down 3 over 2. You could go down 1, 2, 3 over 1, 2. Slope is negative 1.5. You do have a y-intercept, it's 2, but like honestly, we're okay. If you use this in point slope form, you're like y minus 2 equals negative 3 halves x minus 0. It's actually a more logical form of equation geometrically, but whatever. Slope intercept is the y when x is 0. If you solve this for y, you'd get negative 3 halves x plus 2. Parallel lines equal slopes. Parallel lines equal slopes. If we have a parallel line passing through another point, the parallel line has to have the same slope, or else the lines will touch eventually. Y minus y1 equals m times x minus x1. Perpendicular lines, opposite reciprocal slopes. If you have a rise over the run, if you go down 3 over 2, you need to go over 3 up 2. You kind of have to like do the inverse in terms of your direction. So that's very important. If your slope is negative 3 halves, a perpendicular slope is going to be positive 2/3. And we have y minus y1 equals m times x minus x1. Ooh. Passing through point 42. Oh, let's go centered. Or no. Let's see if we can figure this out. Make it harder. I'll do it both ways. What if both of those points were points on my circle? Yeah, there's a circle. Well, there's actually an infinite amount of possibilities here. So I'm going to say that I wrote the question a little bit wrong. I'm going to say circled centered at the point 42 that has a y-intercept of 0, 2. A point 0, 2. So centered at 4, 2. It's got that. Here's my circle. Okay, cool. So what do we need for a circle? We need the center, because the circle is defined as all XY points that are the same distance away from a center point. We have the center point. We need to figure out the distance that all points are away from this XY point. What is this distance? Well, like you could just visually see it's a horizontal distance and you could count if you wanted to. If you wanted to, use 0, 0, 2, and 4, 2, and use the Pythagorean theorem. Sure, here's your a squared, here's your b squared. 4 squared, square rooted is going to be 4. Like you could count and say this distance is 4. 1, 2, 3, 4. This distance is 4. So now we know that it's all XY points that are 4 away from 4, 2. We have now our triangle where we have our X distance, subtract if this was XY, X minus 4, Y minus 2. Again, you kind of like start over and you understand that subtracting numbers gives you the length. So from 4 to X is X minus 4. From 2 to Y is Y minus 2. You get X minus 4 squared, A squared, plus B squared, Y minus 2, equals C squared. A squared plus B squared is C squared. And that's going to be the equation of the circle, and you could graph that. This one's like easier than the previous one. You got the point -2, 1. Distance of 5 away. Okay. What are easiest distances? Just like to the right 5, down 5, left 5, up 5. So 1, 2, 3, 4, 5. Here's this point 3, 1. That's -2 plus 3. Left, -2 minus 5. No, sorry, -2 plus 5. -2 minus 5. It's going to take me to -7, 1. Now let's work on the y's. Y minus 5 is -4. Whoops. And then 1 plus 5 is 6. Great. Those are 4 other points. What's another point? Well, this distance is 5, right? We have a circle whose center is -2, 1, whose XY points are 5 away. Could we understand that our equation for our circle would be x minus -2, which is x plus 2, squared, y minus 1 squared, equals c squared. Cool. Could we use that to help us potentially? Yes. We could pick an x value and plug it in and then find the y value, though that's actually a little bit tricky for you guys. Could you understand that there are easy triangles with the Pythagorean theorem? 3, 4, 5. 3 squared plus 4 squared is 5 squared. Just a beautiful number. Probably the better way to do this, where you go over 3, 1, 2, 3, and up 4, 1, 2, 3, 4. And if this is over 3, up 4, this is still going to be 5, and this is the 0.15. and all variations of 1, 5. So if you plug in 1, you get 3 squared. If you plug in 5, you get 4 squared. All variations of, oh, not all variations of 1, 5. It's not going to be symmetrical that way. If you went left 3, you'd get negative 5, 5. If you went instead over 4, 1, 2, 3, 4, up 3, 1, 2, 3, you get 2, 4. That also works. If you plug in 2, you get 4 squared. If you plug in 4, you get 3 squared. Anyways, like, there's a lot of other points using this 3, 4, 5 idea. And the last one's cool. Just like line practice, which is good. I wish we had more circle practice, but it's fine. We got a perpendicular line to that passing you the point negative 1, 4. We could kind of just look at this equation and see that the slope is negative 1/3. That means the perpendicular slope is going to be negative 3. Rise over run, opposite, reciprocal. So we have y minus 4 equals negative 3 x plus 1. Very good practice. Ooh, this is why we did this. Because we have not asked you to solve for y in many of these equations to find the slopes, and you're going to see that on your quiz. So how do you solve for y here? You can subtract 3x and then take the opposite of everything. Or you could have just like added y subtract 5 and you get y equals 3x minus 5. The other way, if you like added y and then subtracted 5, you can have y on the right side. It's totally fine. Here, we see that the slope is positive 3. If you looked at this and thought that the slope was positive 3, you might have gotten lucky. But you got to check. Here's my y distance. Here's the common ratio. Here's my x distance. And that actually gives you all of your x, y points that follow this ratio of y's per x's. I honestly really understand lines geometrically now that I've taught this. This is not a y-intercept. This is just a point. My bad. Perpendicular line. How do I figure out the slope of this line? I had to solve for y. Hopefully you guys remember solving for y. There's a slope. A perpendicular slope is going to be positive 3/2. Your new equation is going to be y plus 3 equals, that's the y distance, this common ratio, x plus 5. Okay, same deal. We have to solve for y to get the slope. 2 divided by 8 is the same as 1 divided by 4. 1 divided by 8, I don't care about. There's a slope, a parallel slope. This is not 11. This is the symbol for parallel lines would be 1/4. You don't need it in y-intercept form. This is perfect. Okay. I hope you understood this and you do this and you're ready for your quiz on the day we come back from the break. Peace.